All right, so the next thing we're going to talk about is dividing complex numbers. So these are usually going to be in the form of a fraction. And remember, I cannot be in the denominator of a fraction for it to be considered simplified because it represents a radical. And we don't like radicals to be in the denominator of a fraction, along with negatives or other fractions. So if we have a fraction with an I in the denominator, we are going to multiply by the complex conjugate to simplify to a real number. Now our complex conjugate is if we have something in the form of a plus bi, then its complex conjugate would be a minus bi. So we're changing the sign in front of the imaginary term. And it would be vice versa. So if we start with this form, then our complex conjugate, we would change the sign in the middle and then multiply those two things together. So the middle term is going to cancel out, and we're going to end up with an I squared, which then becomes a real number. So if we start by simplifying problem 17, so we have this I in the denominator. So I'm going to put both sets in parentheses, and then we are multiplying by the complex conjugate. So again, we're going to have 4 and 3i again, and then we're changing this sign in the middle to be a positive. So that means that we have two foiling problems to simplify. So if we start with the numerator, we would take 3 times 4, so that's 12. So 3 times 3i is 9i. Negative 2i times 4 is negative 8i. And negative 2i times positive 3i is negative 6i squared. Over, and then we're going to multiply the denominator. So 4 times 4 is 16. 4 times 3i is 12i. Negative 3i times 4 is negative 12i. Negative 3i times positive 3i is negative 9i squared. And then we're just using our simplifying rules. So we're going to start with the I squareds and change them. So remember, I squared is really the same as negative 1. So negative 6 times negative 1 is really going to be a positive 6. And then down here, this is really going to be a positive 9. And then now we can combine like terms. So 12 plus 6 is 18. 9i minus 8i is going to be a positive I. And then 16 plus 9 will be 25. And then those cancel out to be 0. And then the last thing we check is to see if all three of our numbers are divisible by the same thing, but they are not. So this is our final simplified answer. All right, next set. So again, we are starting by putting parentheses around it, and then we're multiplying by the conjugate. So again, we're just changing the sign in the middle. So we're going to multiply by 3 plus 2i to both the top and the bottom. So if we FOIL, starting with the top, 2 times 3 is 6, 2 times 2i is 4i, I times 3 is 3i, I times 2i is 2i squared. And then our denominator, 3 times 3 is 9, 3 times 2i is 6i, negative 2i times 3 is negative 6i, negative 2i times 2i is negative 4i squared. Now we're just simplifying. So again, starting with the I squared terms. So remember, that's really a negative 1, so this will simplify to be a negative 2. And then this one simplifies to be a positive 4. And then we can combine like terms. So 6 plus negative 2 is 4. 4i plus 3i is 7i. And then in the denominator, we have 9 plus 4, so that's 13. And then negative 6i minus 6i is 0. And then 4, 7, and 13 don't have a common factor, so this is our final answer. All right, next problem. So again, I'm going to put parentheses around the denominator. So the numerator doesn't need one because we only have one term. So our complex conjugate is going to be 2 minus I. So in the numerator, we're just distributing this time. So 2i times 2 is 4i. 2i times negative I is negative 2i squared. Denominator, we have to FOIL. 2 times 2 is 4. 2 times negative I is negative 2i. I times 2 is positive 2I, and I times negative I is negative I squared. And again, we start with the I squareds. So negative 2 times negative 1 is really the same as positive 2. And then a negative 1 is going to become a positive 1. So if we combine, we can't combine 4I and 2. So we're going to move the 2 to the front. So this is 2 plus 4I. And then 4 plus 1 is 5. And negative 2I plus 2I cancel each other out. And 2, 4, and 5 do not have a common factor, so that is going to be our final simplified answer. All right, next one. So this is really the same idea as saying 0 plus 3I. So my complex conjugate is going to be negative 3I, so we're just multiplying by a negative 3I to both the top and bottom. So 4 times negative 3I will be a negative 12I. 3I times negative 3I is negative 9I squared. And then now we are just simplifying. So my I squared is really a negative 1. So this is really going to become a positive 9. So now I have negative 12I divided by positive 9. And then I can simplify negative 12 over 9 because they're both divisible by 3. So if we divide each by 3, this will become negative 4I over 3. So that will be my final simplified answer.